A tumor is injected with zero point 0.8 grams of iodine 125, which has a decay rate of 1.15% per day. We're going to write an exponential function that represents this after t days. So the generic function that we're going to write is going to be a of t is going to equal a times b to the t power here. T is going to be our variable because it tells us right there. A is going to be our starting amount, and we are told that the starting amount is 0.8 grams. We'll put that in for the A. The B is what we need to multiply by over and over again. T right now is our variable. Well, it's a decay rate of 1.15% per day, so it's 100% minus 1.15%. That's going to be 98.85%. And we want to change that to a decimal by dividing by 100, or we're 2 spots to the left, but either way, we're going to end up with 0.98885 there. So that would be our equation, and to find out how much would be remaining after 60 days, we just put 60 in for t, and then we just use our calculator to solve it. And when I did that, it'll tell you what you should round it to, and there should be a 60 right there, not a t. So after 60 days, we're going to have about 0.399659. And again, it will tell you what to round it to. I'm trying to look at my calculator at the same time I'm writing, and that's not going too well. There, that's a lot of decimals, and it won't ask you for that much. Next one I'm going to get you started on. So the equation n of t gives you that equals all that stuff there, models the number of people in town who have heard a rumor after t days. As t increases without bound, it sounds like a bunch of fancy math terminology there. What does n of t approach? Well, we really want to put a really large value in there for t and kind of see what happens. And you're kind of new to limits, understandably. So if we were to put, let's say, 1,000 in for t, let's just have a t be 1,000. So 1,000 days later, where this rumor bin going to be? And if you put 1,000 in for e to the negative 0.7 times 1,000, if you put 1,000 in there, my calculator is actually displaying 0. Not because it does equal 0, but it's because there's so many zeros out there before we round it. It's so close to 0, it is 0. And when you get more acclimated with limits, you'll understand this a little bit better. So we're going to almost treat this like it is 0. So if I were to do 49 times 0 for this thing, it's really going to be 0, and it's going to be 450 over 1, which of course is 450. So that would be the approaching value. That's how many people we would expect the maximum number of people who would have heard this rumor based on this equation.